Alright, congratulations. Make it to lesson 7, which is the second and last lesson of Bumblebee Math. Let's take a look real quick at what it is our objective is and what we're trying to learn. Which is all that objective means. What are we trying to learn here? We are trying to learn that to use a letter for the unknown and draw and solve problems using units of 6 and 7. So we'll be working with 6s and 7s quite a bit. And we're going to be also working again with letters to represent the unknown. First part is a matching part. It says match the words to the correct equation. So a number, and we don't know which number. Since we don't know which number, that's known as the unknown. A number times 6 equals 30. Now you can see right over here, oh, there's an n, which is for number times 6 equals 30. So we're going to match that up. 7 times n, 7 times a number, equals 42. Do we see that anywhere? Look right over here. 7 times n equals 42. There you go. That's all I'm going to do with you on these ones. I think you can figure out this is pretty straightforward. You are welcome to pause it and finish doing the rest of these up and lining them up, matching them up with their correct equations over here. So I want to jump right down here to number 2, which says to write, hold on one sec, there we go, write an equation. Remember, an equation has to have an equal sign, so we're going to write an equation to represent the tape diagram below and solve for the unknown. So first thing we need to do, find the equation. I'm looking, we have a tape diagram here, and there is 8 in each group. Or there's, 8 in each group. Question is, how many groups do we have? I count 1, 2, 3, 4, 5, 6. I have 6 8s, or 6 groups of 8, or 6 times 8, and the unknown is the total, which is k. 6 times 8 equals k. Now, to solve 6 times 8 equals k, you could do the distributive property and break up the 6 into 5 and 1. Or, if you need to, you could do 8 times 6. If that helps you. I'm going to count by 8s here since I have the tape diagram. So I'm going to start with 8. Plus 8 is 16. 16 plus 8 is 24. 24, and that's halfway through, is 24. So that's 24 plus 8 to 6, plus 8 is 16, plus 8 is 24. 24 plus 24 is 48. So k equals 48. Let's go ahead and go on to the next page. This talks about model each problem with a drawing, then write an equation using a letter, don't forget the letter, to represent the unknown and solve for the unknown. So all this is about using that letter to represent the unknown. We're going to draw first, draw, then write. Read, draw, write. Let's read it first. Each student gets 3 pencils. There are a total of 21 pencils. How many students are there? So each student, let's draw a circle for a student gets 3 pencils. That's one student and their 3 pencils. Okay, how many, we don't know how many students there are, but we know that there's a total of 21. So we're just going to keep counting by 3. So that's 3. And here's another student, 4, 5, 6. Another student, 7, 8, 9. Another student, 10, 11, 12. Another student, 13, 14, 15. Another student, 16, 17, 18. Another student, 19, 20, 21. So we could say blank, or we're going to put a letter in there, S, students, times 3 equals 21. Now how many students do we have? We need to solve that for S. We have 1 student, 2 students, 3 students, 4 students, 5 students, 6 students, 7 students. So S equals 7. S was the unknown. We didn't know how many students. Each of them gets 3 pencils, and that gives us total 21 pencils. 7 students with 3 pencils each gives us a total of 21 pencils. Alright, on to B. Henry spends 24 minutes practicing 6 different basketball drills. He spends the same amount of time, which means we have equal groups on each drill. How much does Henry spend on each drill? Okay. We have a total of 24 minutes. Which means if we want to do multiplication, we got to put the total over here. So it's equals 24. We have the 6 different ones. 6 times blank, or we could put D for drills. Or we'll use, no, I'm going to take away the D. Whoa, sorry about that. I'm actually going to say, okay, we're going with D apparently. How are we going to figure out D? We know that we have 6 different drills, so let's draw. Let's go ahead and do a tape diagram this time. Actually, I'm going to do a number bond. And here's how I'm going to do it. 24 total minutes. 6 different drills. So we need 1, 2, 3, 4, 5, 6 different drills. Now we're going to split up those 24 minutes into those groups. So we're just going to count by ones till we get to 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24. So that's our total is 24. Match those 6 groups up. Those 6 groups are 6 different drills. How many minutes of a 24 total minutes? How many did they spend in each group? You count what's inside the group. In the group is 4, 4, 4, 4, 4. So D equals 4. Because 6 times 4 equals 24. They spent 4 minutes in each group doing that drill. Okay, we're going to move on down to C and D. Let's look at number C. Jessica has 8 pieces of yarn for a project. So there's 8. We're going to circle that number. Each piece of yarn is 6 centimeters long. What is the total length? We now are looking for the total. We don't know what that is. So 8 pieces of 6 centimeters equals how many total? That's what we got to find out. And we're going to put T for total. So we're trying to find T. What is the total? 8 pieces times 6. So we're going to draw a tape diagram. We're going to draw 7 lines in there. 1, 2, 3, 4, 5, 6, 7. There we go. So that's 8 pieces, and each one is 6 centimeters. So we have 8 groups of 6, or 8 groups of 6 centimeters. We're going to count by sixes. We're going to count by sixes halfway. 6, 12, 18, 24. This is the half mark. 24. So this half equals 24 plus, and we know it's half, so we're going to do 24 again. 24 plus 24 equals 48. So 8 groups of 6 centimeters equals 48. So T equals 48. 48 is our answer. Remember, you can go back on these if you get stuck. Go back and practice again and again and wonder about how we got to the answer and try different ways. If the tape diagram doesn't work for you, use number bonds or arrays. All of that is fine. Try different ways. Last one. Ginny measures 6 milliliters of water into each beaker. She pours a total of 4 milliliters. So here's our total. How many beakers does Ginny use? 6 times blank. We know 54 goes over here. That's our total. And we got the 6 from here. So we're going to use, let's use the letter A. 6 times A. A is the unknown. We do not know 6 milliliters into how many cups gives us 54 milliliters. Okay. We need a total of 54. I'm going to again do a tape diagram. I know one of my numbers is 6. 1, 2, 3, 4, 5. Those are my 6 groups. I know I need to get a total. All of this needs to equal 54. So I can count by 54. I'm going to count by, you can count by ones. You can count by fours. I'm sitting here wondering, how can I get from 6 to 54? How many times do I need to do 6? Counting to 54 by ones is going to take me a long time. Is there an easier way to do this? That's what I am wondering right now. Thinking about, it's going to be hard to do an array because I need 54 total. Well, that may not be too hard. This is what wondering does. I'm going to erase this, which takes a little bit of time. See, even Mr. Wade has to spend some time wondering what's the best strategy to use to solve this. I actually ended up, after I made the tape diagram, I was like, oh, I don't like it for this one. So now I'm going to make, over here I'm going to make little rows of 6. Two, 3, 4, 5, 6. Okay, there's 6. That is 6 milliliters. We're going to count by 6s, or by 1s, but 6 in a row, to see how many rows we end up with. So that was 6. This is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. Yes! We did it. So here's our 6. We got to figure out how many rows do we have. So let's go ahead and count down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So A equals 9. So what is A? That's how many beakers Ginny uses, is 9 beakers of 6 milliliters. Whew. So you see, on this problem up here, we used a tape diagram. On this one, we used an array. Up here, we used a number bond. And up here, we used equal groups. So there are a lot. We just used 4 different ways to solve these problems. There are lots of different ways. It just takes trying and wondering if another way is going to work better. Or wondering what is the best way. All right, good luck, and see you next time.